Okay. So this is the data set, right? GitHub/Swapnil Saurav, and then you have machine learning. So we have already seen data preprocessing and marks data for simple. We'll be using this third data set called startups. Okay. This has been designed for multiple linear regression. Now, this has how many columns?
5 columns total.
5 columns total,
Yes.
right? Right?
Yes.
So can you look at the columns and tell me what this problem could be about?
It's about profit, predicting profit.
It's about
Profit.
profit. What profit? We have
What
5
all the
columns.
costs
You're
are
talking only
there and
about
what
one.
is the profit?
Sorry.
What all cost is there incurred by the company and what all profit they have
Uh-huh.
gained?
Expenditure and
Okay.
regarding to state, on which state, how much we are spending, how much we are getting profit.
Correct. So what do you think the problem could be? So we are talking machine learning, right?
Yeah.
So what do you think the problem could be or objective could be here?
Based on what all expenditures that we have, what will be the profit?
Yes. So this is data about startups. Okay. And what we are looking at are their R&D spend, admin spend, marketing spend, okay, and in which state the company is based in. Based on these factors, we are trying to predict their profit. Okay. So of course, this is your why, profit is your
Yes.
why. We are here to predict profit based on 4 conditions. Now,
conditions.
this is a multivariate example, right? You have more than
Yes.
2 columns. Okay. And X, all these 4 will be X. Okay.
Yes.
So let's, uh, you know, start doing it. But before, what are the pre-processing steps that we will need to do? What are the
Then
pre-processing steps generally that we have studied so far?
to encode the data,
Okay.
then we need to check for missing values.
Okay.
After that, column transformation.
What is encode and column? Together you can say, no, handling categorical value.
Yeah, handling categorical value.
Okay.
Yeah.
And what else? Normalization, scaling,
Yeah, scaling, normalization scaling.
right?
Yeah.
So here, which of these process will you follow here?
There are some missing values here.
Where there is missing value?
0.
There will be no spend done on that.
0 is not a missing value. Missing value is not 0.
Okay.
0 is not missing value, isn't it?
Yes.
So which all process will you follow? Fast. You should be fast enough to talk about these things.
Any missing values are there? No.
There is no missing value here. That's what I said. There is no missing
So
value here.
we will directly do encoding and column transformation.
Okay.
Yeah.
Okay. For this one, we will do state. What else? Anything else? Scaling. What about scaling? Normalization. Should we do it here or not? Not required. Okay.
No.
Not required because even though these numbers are big, but all the columns have similar range. Okay. Here you have 6 digit, 5 digit, 5 digit, 5 digit and 6 digit. They are in similar range. Correct. Okay. So 6 digit is on the lower side, like, 100K, 1 lakh. And 5 digit is in the higher side, like 40,000, right? 50,000, right? So, okay, here you have 6 digit as well. So they are in similar range. So we don't have to perform scaling. If it was like 2-digit and 6-digit, then yes. But since they're in similar range, there is no need to do normalization. Okay, we can avoid doing normalization. Okay, so let's read this data. So I'm going to click on raw and I'm going to copy this link. And now we will go to PyCharm. This is the same yesterday's program. Okay, so I'm here. I'm going to replace this with this value. Okay, now X here is column 0, 1, 2, 3, right? 4 columns, right? So 0, 1, 2, 3 I need. So I need to put 4 here.
Yes.
And Y will be 4th column.
4th column.
Okay. Okay. Now missing value not required. Categorical value, yes, it is required. So we will uncomment this. Now here, okay. Okay, so we are saying label encoder, one hot encoder, and which column has categorical value? Column 4th column, right?
4th
3rd
column.
index.
Yeah.
Right? So I'm going to replace here with 3.
3.
All right. And one hot coding will be 3, right? Okay. Now this should give us X. So what I'm going to do, I'm going to comment this 32 column for now. Let's print X and see the final result. Okay. And then we'll come back. Now, of course, these columns are not same. Okay. If you want to see the relationship, okay, so it's always Y versus X, right? And since the plotting that we are going to do will be 2-dimensional only, right? It cannot be 3-dimensional like on screen. So we'll take 2 columns here. So Y is always the profit, right? So I'm going to say profit. And on the X, I will say administration. I'm going to take administration expense. Okay. So your X is administration. And on the Y, we'll say profit. Okay. Now I don't have to write this. I'm going to delete it for now. Then you have train test split. It's all good. Okay, scaling not required. Okay. Now all these things we'll do it later. Okay. I'm going to put again comment here. And once we understand our X, we'll come back and we will run this. Okay, this is also done yesterday. Okay. So let's run and see how X looks like. There's an error somewhere, looks like, right? There's one, let's see. No, I don't think there's error. Okay. So let's see how X looks like after doing column transform. We have not deleted. We need to delete one. Need to delete one column, right?
Yes.
Okay. Now let's first understand this X. To see what happened. After doing column transform, the column transform became the first 3 rows. Okay, did you understand? After we said 3, okay, after doing one hot encoding, it came in the beginning. All right. So this one will work well. So since it's in the beginning, we will drop the first column itself. So now you will have from here, from second column onwards, we will have in X. Okay, great. Okay. Now let's run it again. And I have not shared the entire screen, so I'll share the entire screen so that you can see the output here. Now see, this is the axis. This is the scatter plot. Okay. On X-axis, you have admin spend. On an Y-axis, we have put profit.
Profits.
When you see these dots, what do you understand? What do you see? Okay, let me take this to Paint and then talk about it. Paint is not. Oh. Okay, so if you see here, we do have a trend. Increasing, right? As X increases, Y also increases. But dots are very far out. So this is a weak correlation.
Yes.
So there's a weak correlation between admin and profit. There is a correlation, right? It is increasing as you increase the admin spend. You do get, you know, positive trend in profit, but it's weak. Now, what I will do, we will compare with all the three numerical columns and see what happens. So we'll go back here. And so we are saying admin versus profit. Here we have R&D, right? R&D versus profit. And here we can say marketing spent versus profit. Okay, so let's run it again. So this is your admin. Okay, so this is what we have seen. There is correlation, but it is very weak. This is your R&D spend. See, R&D spend looks like very strong correlation. You see, dots are very closer to each other, right? So if you draw a regression line, the errors will be less. So very strong correlation. And this is your marketing spend. So marketing spend, if you see, this side, lower side, it is weak, right? Very far, dots are far off. But towards the end, you see, it's almost closer to a line. So this is again positive correlation. Okay, stronger than admin spend, but not as strong as R&D spend. Okay, so from graph we can get this. We don't have the numbers, right? We have not calculated the correlation, but we'll see. Okay, from the graph, it looks as if this is better than admin, but not as good as R&D spend, right? Okay, now let's start applying our model. So let's go to scaling is not required. Okay, run the model. I'm going to uncomment it. We are still doing multiple linear regression, isn't it? So multiple linear regression has same, okay? For the algorithm, it doesn't matter whether you are doing simple or multiple. Okay, the algorithm is same. Okay. So I'm saying linear regression, I'm putting X train. Okay. Now here you see, since we have how many X's we have now? How many X we have now?
We have 4x.
We have 5X. Data is in front of you. Still you can't say?
Yeah.
How many X we have?
1, 2, 3, 4, 5.
5X. There are three unique columns, three unique states. So three unique state created three columns and we removed one. So you have two columns for state. So you got 5 different variables. Okay, so now when you run this coefficient and intercept, coefficient will be 5 coefficient for each of these values. So we'll end up with 5 coefficient and 1 intercept. Okay, so let's run the model and see what happens. So you see, this is the coefficient. This is the coefficient. Okay. Okay. Now let's go back to the data set for once. And we have state as New York, California, and Florida. These are the 3 unique states. So which one will be the first column, second column, third column?
New York, California.
California will be the first column, Florida will be the second, and New York will be the third. So we have dropped the first one. That means we have dropped California. So we have
Yes.
Florida and New York. So actually, I'll also show you how you can see the output itself. But now we know the first column is Florida, second column is New York, third is R&D spend, fourth is admin spend, and fifth is marketing spend. So if I go back here, okay, so what we'll do here, okay, so you say here y equal to minus 379 to the power 3.
3.
This is plus 3. That
Yes.
means
To the power.
minus 3794.2. This is the coefficient, right? This into your Florida value. Florida is there or not? So it will be either 0 or 1, right? It will be either 0 or 1. So Florida is there, then you have to minus 3700. If Florida is not there, then ignore. Value will be 0. Okay. Minus. This is also minus. So
Yes.
here is going to be minus 3090.1. And this is California.
California.
California, I'll be either 0 or 1, right? Next, third value, 8 point, so it is minus 1, right? So it will be 0.8. So plus 0.8 to R&D spend, right?
Mm. Yes.
Next, minus. Okay, so minus.
Zero.
Minus 5.5, then you have minus 0. That means, okay, it
Zero.
becomes 0.05,
Yes.
right? And this is going to be your, what is this? Second column is admin spend.
Admin spend.
Okay, then again plus. Plus, you have again power minus 2.
Minus 2.
So point
0.0.
0.02, okay, 2, and this is your marketing spend. Okay, a plus the coefficient. How can we forget the coefficient? Right? So we will say plus. Coefficient is 5. Okay, we'll put it here itself. R&D spend. I'll put R&D, okay, so that we can save some space here. We'll say marketing. Okay, plus it is 56650. 56650. This is the equation. Now, if you know how much money you are spending on R&D, how much money you are spending on admin, how much money you are spending on marketing, whether you are based in Florida, California, or any other state. If you are based in any other state, Florida and California both will be 0, right?
Yes.
Okay, and this is what you will get. It will tell you how much profit you can expect. Okay, so this is your solution. Okay, so now you are able to predict. And of course, we have y test and y. If you see, what is the RMSE value? RMSE value is 7,562. R square is 0.96. 0.96 means we are doing good job, right? We are going better. Now, your variance is 0.88 and bias is 0.9. Now, you see this. Bias is 0.96. The training data is 0.96. Variance will be 0.88. So, which is right, okay? Variance will be less only, right? Variance will be a train.
Yes.
Variance is your validation data, test data. So, it will be less. It is less. But now you see how much less it is. Okay, how much less it is. Okay, so what I'll do, okay, we'll copy this and paste it here. Case 1, when all the columns are taken into account. Okay, perfect. Okay, so this we are done. We are done, right? But now the question comes here, are all these 5 columns important? Can we predict using 4 or 3 or 2 or 1, right? Or all 5 are important, right? If you have 20, should you use all 20 or not? Okay. So for that purpose, if you are doing linear regression, we have OLS test. Okay. So we will perform OLS test and see the impact, okay, of each of the columns on the final prediction. Okay. So I'm going to say here testing. Okay. So see, you have actually initially we started with 4 columns, correct?
Yes.
First thing first, okay, if your experience, okay, and okay, so I always say experience will outscore or will always be taken into consideration when you have to have a choice between statistics or experience. If your experience says yes, all 4 of these columns or the 5 columns that we ended up, all 5 are important. All 5 are equally important for prediction of profit. Okay, then this is the answer. We stop here. But let's say you are not sure. You want to check, are these really all, I mean, all of them equally important? Then we need to test each one, okay, and see which one is contributing more to the analysis. Okay. So we have a OLS metric here. Okay. So we are going to import from, it is in stats model. Okay. Stat models. Okay. Dot API import OLS. Okay. So this is faster way of implementing um, your your model. Okay. And also we will rename it. So I'm going to say import stats models dot API, okay, as SM stats model. Okay. Now let's run this and see. So here you say x equal to, we'll treat, because x is what is important for us, right? Have to treat x. So I'm saying x equal to SM dot add constant. Okay, and I'm adding all the constants. So basically I'm saying x equal to x. Okay, and now we are going to do summary. Okay, summary 1 equal to OLS. Okay, now what I'll do is I'll put x1 here. Okay, because we'll create multiple x's. So x1 equal to x, okay, at constant. So I'm adding all x to this x1. OLS of y comma x1, okay, dot fit perform, and then give me the summary after doing fit. Okay, now let's print the summary. So I'm printing, okay, so I'll call this as summary of all x slash n. I'll put hyphen slash n, okay, and I'll say here summary 1. Okay, now see what happens. See the output of summary. This is our first graph. This is our second graph. This is our third graph. Okay, so we've got RMSE. Oops. Which line? Line 98.
90.
What does it say? 98 fit dot summary. Is finite not supported input types and the input could not be safely caused to any supported type. Okay. I think we need to make some change here. Show me the x value. So problem could be with x or x1. right? Y, sorry, y or y1. So what is y for us? Y is this. Okay. Now x is this, right? Yeah, correct. So this is the final x. This is final x, and what is final y? Final y, we are not touching, right? I same. So OLS stats verify dot add constant x. Okay, just give me a second.